So time for another physics video since I'll be gone for track again. Today is 16.1 Illumination. So we're going to do two problems involving the two different kind of math things we have. So this one reads, a three-way bulb uses 50, 100, or 150 watts of electrical power to deliver 665, 1620, or 2285 lumens in its three settings. The bulb is placed 80 centimeters above a sheet of paper. If an illumination of at least 175 lux is needed on the paper, what is the minimum setting that should be used? So we're going to set this up. We're going to use our equation E is equal to P over 4 pi r squared. We have a radius in centimeters, which is pretty much worthless. So I'm going to rewrite that 4 pi times 0.8 squared. And then we are trying to find P. So even though it gave us three different measures of luminous flux, we are trying to find the luminous flux that we need. And it gave us an illuminance that it desires of 175 lux, or Lx. So we're trying to solve for up here. So what I'm going to plug into my calculator is I would plug in 175, and I'm going to multiply both sides by the bottom here. So 175 times 4 pi times 0.8 squared, or 0.8 times 0.8. And that is going to equal our x. And our x, I'm going to find out, is 1,407 lumens, so Lm. So that means that the first setting of 665 is not going to be enough, so I would answer this question and just say something like at least the 1620 lumen setting must be used. Okay, that one was pretty easy, I thought, so we'll move on to the next one. Our next one, it says, Ole Romier found that the average increased delay and disappearance of Io from one orbit around Jupiter to the next is 13 seconds, and asks us how far does light travel in 13 seconds. So yesterday we wrote down c, the speed of light, is equal to 3.8, 3.0 times 10 to the 8th. Where's my eraser? 3.0 times 10 to the 8th. And that's in meters per second. So since it's already in meters per second, I can just take 3.08 times 10 to the 8th times 13, and I'll get an answer in meters. And that would be using our equation D is equal, sorry, I can't talk today. V is equal to D over T. Then I'd rearrange that. I'm trying to find a distance. So what I'm going to get, if I plug that into my calculator, is I would get 3.9 times 10 to the 9th meters, or 39, and then 8 zeros. 0, 0, 0, 0, 0, 0, 0, 0. So yeah, scientific notation. Each orbit of Io takes place, well, I did this twice. Each orbit of Io takes 42.5 hours. Earth travels the distance calculated in part 1 in 42.5 hours. Find the speed of Earth in kilometers per second. So this is kind of a throwback to that first chapter. So I want kilometers per second. I have the 3.9 times 10 to the 9th meters, and it tells me that that's going to take place in 42.5 hours. So I'm going to go ahead and convert meters into kilometers. So 1,000 meters is 1 kilometer. Then to get my hours into seconds, I can do that in 2 conversions. I could say 1 hour is 60 minutes, and then 1 minute is 60 seconds. And that's going to give me the answer I want in kilometers per second, because all of those are going to cancel out except kilometers and seconds. So into my calculator, I type 3.9 times 10 to the 9th divided by 42.5. Then I would take that answer and divide by 1,000. Then I take that answer, divide by 60, take that answer, divide by 60, and I would get 25.5 kilometers per second, which is how fast Earth is traveling. Cool. Thanks. Sorry my handwriting wasn't great today, and I kept messing up talking. Have a good day.